This is 4-9, isosceles and equilateral triangles. Let's take a look at the warm-up. Okay, for the first one it says to find each angle measure. Well, since this is an equilateral triangle, all sides are congruent. That also means that all angles are congruent. It's equiangular. And so these are going to be 60 degrees each, since we know, based on the triangle sum theorem, that all three angles of a triangle add to 180. Okay, every equilateral triangle is isosceles. Does every equilateral triangle have at least two sides congruent, which is the definition of isosceles? And the answer is yes, so I would say this is true. Every isosceles triangle is equilateral. Okay, well, let me think. If I have a 5, 5, 7. This is an isosceles, but is it equilateral? No. So this is false. And my explanation why is seen in my image here. Okay, some vocabulary words for this section. So we're going to be talking about isosceles triangles. They have at least two congruent sides. Those congruent sides with the tick mark here, those are called the legs. The vertex angle is the angle formed by the two legs. So if you follow those two legs, this angle 3 here is our vertex angle. The side opposite the vertex angle is called the base. Kind of makes sense if you redraw this. So the angle 1 and angle 2 are on the bottom there. That's my base. The top angle is that vertex angle. And my two congruent sides, which are right across from the base, right across from the congruent angles, are called the legs. So we have our base angles, which are the two angles on either side of that base. Okay, isosceles triangle theorem. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So what we're saying is if these two sides are congruent, I'll draw a little line, then the angles opposite are congruent. So in this case, that would mean the angle B is congruent to angle C. So the hypothesis is if you have this, then the conclusion, angle B is congruent to angle C. Now the converse of that, if the base angles are congruent, then what I'm saying is the sides opposite are congruent. So now we know that DE is congruent to EF. Example 1, using the isosceles theorem, the length of XY is 20 feet. That's marked. Explain why the length of YZ is the same. Well, first of all, we have this 40-degree angle down here. And because of the linear pairs, angle YZX, the measure of angle YZX is equal to 40 degrees because of linear pair. So this angle right here is also equal to 40 degrees. So I know that these angles are congruent. Since those angles are congruent, I know this is an isosceles triangle. So since angle YXZ is congruent to angle YZX, then the triangle is isosceles. By the converse of the isosceles triangle theorem. So I know that XY is congruent to YZ. Since XY is 20 feet, then YZ is 20 feet. Okay, to find the measure of the angle. So since I don't know angle D and angle F, but I know that they're congruent to each other because of the isosceles triangle theorem, I can call each of these X. And so what I have is X plus 22, which equals 180 degrees. So if I simplify this, I get 2x plus 22 equals 180. 2x equals 158. And x equals 79 degrees. So the measure of angle F equals 79 degrees. So really what's happening is this is the triangle sum theorem. Okay, and that the isosceles triangle said that the base angles are congruent. So I know that I could put x for each of them since I wasn't provided a variable anywhere in this problem. And basically what I was doing is I took 180, I subtracted 22, which is 158, and then I'm dividing by 2, since there are two congruent angles here, and my answer is 79 degrees. Okay, for the measure of angle G now. Notice that my base angles across from the congruent sides are also congruent because of the isosceles triangle theorem. So I know that angle HGJ is congruent to angle HJG by the isosceles triangle theorem, where if the two sides are congruent, then the base angles are congruent. And so I can set these equal to each other. So x plus 44 is equal to 3x. And to solve, I could subtract x from both sides. So we have 44 equals 2x. Divide both sides by 2, and x equals 22. To find the measure of angle G then, I'm going to replace the x with 22, and I get 66 degrees. And I can plug this in for all of these and check. So if I do 3 times 22, I also get 66 degrees for the 3x. So for the measure of angle J, it's equal to 3x. 3 times 22, which is 66 degrees. And that's what I wanted since I knew the base angles were congruent. And here's a corollary. If a triangle is equilateral, then it is equiangular. And if a triangle is equiangular, then it is equilateral. So notice in example 3, I have an equilateral triangle. So I know that all of the angles are going to be congruent. So every angle is 2x plus 32. So I can do 2x plus 32 plus 2x plus 32 plus 2x plus 32. Or I can just do 3 of those. 3 2x plus 32s are going to add up to 180 degrees. Another thing I know is that this is going to be 60 degrees. So I could have just started with this. But regardless, I can then distribute if I want. So I could get like 6x plus 96 equals 180. Subtract 96 from both sides. 6x equals 84. Divide both sides by 6. And x equals 14. And I can double check my work. If I plug 14 in here, I get 28 plus 32, which is 60 degrees. It makes sense because every angle is going to be 60 degrees. Okay, in the example B, this would be the second corollary. If a triangle is equiangular, then it is equilateral. So I know that all these sides are congruent to each other. So I can set 5y minus 6 equal to 4y plus 12. And again, that was because I know that segment ON is equal to segment OP. And I can start solving now. So subtract 4y from both sides. While I'm at it, I'm going to add 6 to both sides. So I end up with 1y is equal to 18. And again, if you plug these in and check your work, they'll be equal to each other. They'd both be equal to 84.